welcome to the video lesson for multiplying and dividing rational functions. To begin with, we're going to look at the process for simplifying a rational function, and then we're going to go through the steps for multiplying and or dividing. For our first example, we look at our numerator, and we have a lot of stuff we can do there. We want to look at the fact that they all have a common factor of a 2. So I'm going to start by factoring out a 2, and what I end up getting would be 2 times x squared minus 9x plus 14. And then we look at that 2 times x squared minus 9x plus 14, and you use your favorite factoring method. And when you do, you should get 2 times x minus 7 times x minus 2. And then if you look at our denominator, again, picking your favorite factoring method, for this one, I would use the butterfly method. I'm going to go ahead and factor that. And when I factor that, I'm going to go ahead and get 5x plus 4 and x minus 7. And now that we have everything within one fraction, we can go ahead and cross cancel. Very important to note that within our numerator and our denominator, there are no plus or minus signs in between terms. So I have 2 times x minus 7 times x minus 2, and then 5x plus 4 times x minus 7. Again, no plus or minus in between our terms. So I'm going to cross cancel these x minus 7s, and then since I can't cross cancel anything else, I'm going to write down what we have left. So my final answer then would be 2 times x minus 2 divided by 5x plus 4. And we have the option here of distributing the 2 if you wanted to. I don't think it's really necessary here. Looking at our second example, we have x minus 8 over 3x squared minus 14x minus 80. Again, we want to look at our numerator first. I can't factor x minus 8 at all, so I'm going to look at our denominator. And for this one, I'm going to go ahead and demonstrate the butterfly method because I have a little bit more space. I have a 3 and a 1. Those two multiply to be a 3x squared. And then for my other value, I have a negative 80. I want two numbers that multiply to be negative 80. I'm going to go ahead and go with a positive 10 and a negative 8. And then for our check process, I'm going to cross multiply here to get negative 24 and cross multiply here to get a positive 10. And if I add them together, I get a negative 14. And the check is that that's supposed to be my middle number. So I know that when I factor my denominator, again, our numerator doesn't factor, I'm going to get 3x plus 10. That's what we get when we read across for our factors. And then we're also going to get x minus 8. Now in this expression, I notice that I kind of have exact opposites. I have 8 minus x, and I have x minus 8. When I divide opposites like this, or cross-cancel opposites, they don't completely go away. What I'm left with is actually a negative 1 in their place. So then for my final answer, I have negative 1 divided by 3x plus 10. Okay, your turn. Go ahead and see if you can factor the numerator and denominator in your turn A, and then check back in and see how you did with your answer. Go ahead and hit pause now, try the problem, and then check back in. All right, so again, I demonstrated the butterfly method here. We have 3 times 1 is going to multiply to be this 3, and then a 1 times negative 7 multiplies to be a negative 7. When we cross multiply and combine them, negative 21 plus 1 does equal negative 20, and that's this middle term, so we know our check works. So when you write your factor, going left to right here, we have 3x plus 1 and then x minus 7. And I notice that I have a common denominator for this x minus 7, so we can go ahead and cross cancel those. All right, we're going to go ahead and list some steps for multiplying and compare those steps for multiplying with dividing and use them to help us simplify some multiplying and dividing expressions with rational functions. Okay, so when we go to multiply, we do have a couple steps you want to make sure that we follow. The first step, very similar to what we had just done, is you want to make sure that you factor everything. And when I say factor everything, I mean factor both numerators and denominators for your rational expressions, or if you have more than two, factor all numerators and denominators. Once you've done that, you then want to try and cross-cancel whatever you can. And then when you're done, you multiply together what's left. When we are dividing, it's very much the same thing except for we have one additional first step. That first step is going to be to flip or find the reciprocal of your second term. And that's because when we divide rational functions, we don't actually divide rational functions. What we do instead is we multiply by the reciprocal. Afterwards, all your other steps are the same. You got to factor everything. And then we're going to cross cancel. And then last but not least, you're going to multiply what's left. So we'll go ahead and do a multiplying problem and do a division problem, and we can walk through the difference between our steps here. All right, so for our first example over here, example number 3, we see we're multiplying terms. Again, I'm going to go ahead and factor everything. If I look at my numerator, I want to try and factor that. I have x squared plus 5x minus 14. Because it's a 1x squared, I can use the diamond method or the butterfly method, pretty straightforward. But what we're going to get is an x plus 7, and then an x minus 2. I can't factor this 9x, so I'll leave it the way that it is. We also can't factor x minus 3, so we'll leave x minus 3 as it is. And then for this bottom term, we have a couple options here. I'm going to start by taking out a negative 1, because it's kind of hard to factor a quadratic when you have a negative as your first term. So if I take out a negative 1, we now have x squared minus 5x plus 6. And then I'm going to go ahead and factor that, write it right underneath here. So what we'll have then is a negative 1 times an x minus 2 and an x minus 3. All right, so we did step 1. We factored everything. Now we're going to move on to step 2. We're going to cross cancel everything that we can. And I see right away that I have an x minus 2 I can cross cancel. I have an x minus 3 that I can cross cancel. And then I'm going to go ahead and multiply together what's left. So in my numerator, I have nothing left except for this x plus 7 to multiply. And then in my denominator, I have that negative sign, so I'll multiply that negative 1 in, and we get a negative x in our denominator. Let's go ahead and compare example 3 to example 4. We see that we are dividing. So our first step, I'm going to go ahead and rewrite everything the way that it was for my first term. We have x squared plus x minus 2 over this x squared minus 9. And then for my second term, I'm going to flip it and make it a multiplication problem. So we're going to get x cubed minus 3x squared minus 16x plus 48 over x squared plus 2x minus 3. All right, if I look at my first fraction, I can definitely do some factoring here. I can factor that as x plus 2 and x minus 1. For my second fraction, I see that it's the difference of squares. I'm going to get x minus 3 and x plus 3. And then for that second fraction, my numerator is a little more challenging, so I'm going to start with my denominator. That's going to factor as x plus 3, and then we have an x minus 1. And what I'm going to attempt to do here is demonstrate how to factor by grouping here. I'm going to group my first two terms and my second two terms, and notice that I group that negative with the 16 there. With my first set of terms, I kind of cover up the squared there, but I can take out an x squared. And if I take out an x squared, then I have an x minus 3 left. And then with my second set, I can take out a negative 16. And if I do, then I am left with an x minus 3 as well. So then I can go ahead and regroup this as x squared minus 16, take out those terms, and then what I have left is this x minus 3. All right, the x squared minus 16 is another difference of squares, so I'm going to actually rewrite that as x minus 4 and x plus 4. All right, now that I have done that, we're going to go back and look at all of our factors and our numerators and our denominators and figure out what can cross cancel here. So I have an x minus 1 that I can cross cancel. I have an x minus 3 that I can cross cancel. And I don't have anything else that I can really cross cancel from here, so we're going to write down what we have left. And when I say multiply everything together, we don't necessarily have to actually multiply it out, but just put it as a product of terms. So what I mean by that is in my numerator, we're going to have an x plus 2, and then we have an x minus 4, and an x plus 4. And then that's going to all be divided by my denominator, which is going to be an x plus 3, and there's two of them, so I'm going to put it as x plus 3 squared. And then I'm going to put some brackets here to show my numerators all together. So I show that I've multiplied it all together, but we don't have to actually physically multiply it out. All right, let's go ahead and look at this your turn B, and then I'll give you guys a chance to kind of try it out. So for that one, again, it is a division problem. What I'd like for you to try and do is flip it first, factor, cross cancel, and multiply together. Go ahead and hit pause when you're ready to try this, and then check back in, and we'll see how you did. Okay, so let's go ahead and look at my steps here. Again, my first official step was to take this second expression, and instead of writing it as a division problem, I multiplied by the reciprocal. After I did that, I went ahead and factored my terms. So I factored the first numerator to be x plus 10 times x minus 4. The x plus 1 doesn't factor. For my second expression, I saw I could take out a greatest common factor of 10 in my numerator, so I took that out. I had x plus 1 left over. And then in my second expression, I noticed that it had a common factor of a 7x, so I took that out, and I was left with an x minus 4. From there, I went ahead and cross-canceled. We cross-canceled the x minus 4s. We cross-canceled the x plus 1s. And then I wrote it down. We have two acceptable answers. We have the 10 times x plus 10 over 7x, or because there's not that much to multiply, it'd be reasonable to multiply it and get this 10x plus 10. The one thing I need to stress, because this does tend to happen, is people forget that I want to cross cancel more, and I see that, well, can I just cross cancel these x's here? And the reason why we can't do that, again, we cannot do that, is because there is this plus sign here. There is this plus sign that is connecting the 10x and the 10. So terms are separated by either parentheses or plus or minus signs. And because we have that plus sign, the 10x and the 10 are connected as a single term. So we can't just cross cancel the x's there. Again, a lot of people tend to like to try and do that, but we can't do that for this one. Let's go ahead and look at the last problem here. This one's a little more straightforward. We have another division question, so we're going to start by flipping it to make a multiplication. If I look at my first term, I'm not going to do anything with it. We're just going to start right away by writing it down. And then we'll flip our next term and make it a 5x cubed over 7. There's not a whole lot to factor here, so I'm just going to do some cross canceling. I know that I can divide 21 by 7. And if I do that, then the 7 is going to cancel. The 21 will reduce to become 3. I know that I can divide 15 by 5. Again, this 15 will cancel. The 5 will reduce to 3. And then I notice that I can reduce the 3's. So the 3's will cross cancel. And what I have left here are my x's. So I'm going to go ahead and kind of write down what we have at the moment. Currently, we just have x cubed over x to the 4th because everything else has cross canceled. When we have these terms, we've got to make sure we subtract the exponents, but you want to keep it positive. Another way to think about it is x to the 3rd will simplify with the 4 and make it an x to the 1st. And since there's nothing left in my numerator, we have to have a placeholder. So I'm going to put a 1 as a placeholder, and our final answer would just be 1 over x. Okay, that does it for our review of multiplying and dividing rational expressions. The homework is the next page. Go ahead and get started, and good luck.